My name is Ted Matsumura, in case that didn't get in the recording. I've been working in the last 10 years at a company called Verint doing DevSecOps and GitOps for what Verint does, which is CX automation, or basically back-end tooling for call centers. So CX stands for like customer experience. It's CX automation is like a nice word for call centers. But basically the bots at your bank are handled by call centers, as are when you call in, you normally don't get a person, you get the IVR, or the automated response system. Before that, I worked at companies, maybe 10 years in the networking companies, doing Ethernet and gigabit Ethernet chips and ASICs, and at Intel. But while I was at Intel, I was also doing network processors. And then Adaptec, back in the 90s, we were doing SCSI Ethernet chips. Then we were playing with ATM, and then we did Ethernet, and we were moving to gig Ethernet. So I'm going to talk about SSL. So SSL is a secure sockets layer, and after HTTP came out in the late 80s or early 90s, and before we had like Mosaic and graphical browsers, we didn't have to deal with HTTPS or SSL. So SSL came out around, I think around late 1980s or early 1990s, and the first one to actually come out was the version 2. So we still talk about things like SSL certificates, but even though SSL's been long deprecated since like 1995 in favor of transport layer security, what we call TLS. So there's multiple versions of SSL. There's now multiple versions of TLS. TLS 0 and TLS 1.1 have been deprecated. So everything now should be TLS 1.2 and preferably TLS 1.3. And TLS 1.3 is preferred because when we get to the post-quantum, you'll see that it's going to actually be required along with compatible protocols like QUIC from Google that's being used now. Certificates, or digital certificates, can verify the certificate and also the hash of the certificate that it's valid. And right now, SSL certs are designed for non-post-quantum, but we're going to see later how they can work today how they are working today with hybrid solutions. All of these slides are going to be made available. I'll actually give you the link at the end of the session, as well as through Linux West Northwest. So these are some statistics from a site called SSL Pulse, and you can cross-reference this data with data that Google keeps on the same stuff, and also vendors like Cloudflare and others have dashboards that try to keep track of this data on their networks, like who the cert authorities are, how the certs differ from each other, how you'll want to make sure your bank has an OV type cert, while 95% of us using Let's Encrypt are just simply getting a DV or domain validation cert, and that's the lowest level. That means anyone who's an admin for that DNS name can get a certificate and make it look like the site's authenticated. Another thing about certs, before I go to the next slide, is certs have a time frame. So you can buy a cert from your favorite vendor, GoDaddy or DigiCert or AWS or whoever, and you might get a 3-year, 5-year, or in some cases 10-year certificate if you pay enough. But the certs themselves only last about 13 months. So if you get a 10-year one, every 13 months you're going to have to regenerate it. You're going to have to, even though you won't have to pay DigiCert or whoever you paid for 5 or 10 years, you're still going to have to generate a new cert. As you know, in a browser bar, you can always look at your cert. You can also run command lines like SSL. I think it's SSL check. I think it's on the next slide. So I'm going to page down here. Okay, so the different types of standards that people in business have to work with are the PCI standard. People in the medical industry deal with HIPAA and HITRUST. People doing government data have to deal with FedRAMP, and FedRAMP has 3 different levels. It has a low, moderate, high, and when you deal with the government, you also have to use FIPS 140-2 or 140-3 ciphers. And what that means is that if you're using a specific OS, like if you're using Debian or Red Hat, you have to verify that the crypto modules in that have been certified. You can actually go to a website and see. And that's why Red Hat and some of the other vendors for enterprise Linux, like Rocky, who's one of the sponsors here, their parent company, CIQ, is a title sponsor here. If you're interested in enterprise Linux, also in addition to IBM's RHEL, take a look at, of course, Rocky, Alma. They've got a table in the exhibition. SUSE is big in the rest of the world, maybe not so big here, but they're an enterprise Linux. Oracle has an enterprise Linux. Anyone can have an enterprise Linux. You can make your own distro tomorrow. But to get FIPS certified and send it through a lab, you're probably going to have to come up with at least $400K, if not by over a 5-year period, it will be in the 7 digits. It will be millions, because you'll need recertifications, third parties to see how. And you may have just get cloned the same exact code that IBM is using for Red Hat, but what NIST, who certifies these FIPS standards, federal standards, wants to see is they want to see the implementation in your distro and the entropy it uses is still secure, because at the end of the day, you're not going to have every part of your user space module for your distro isn't going to be the same as Red Hat's. I mean, the fact that you have to call it something different than IBM Red Hat Linux trademark means you've got a different application now talking to that OpenSSL and any other crypto layers underneath. So enterprise Linux just means you can probably go to a FIPS or a NIST or a FIPS website and see that the crypto modules are validated. So one of the standards, if you take money for a coffee shop or whatever online, or you sell t-shirts online, you or your vendor have to be PCI compliant. And so whether you're PCI compliant with 3.2 or 4, you can't use these old versions of SSL and TLS. You can still use TLS 1.2, and there's a reason to do that, because if you're a social media site or you're selling widgets for $1, maybe you need to support 10-year-old computers that aren't getting patched. You can't afford. If you look at Amazon's site and you find a 10-year-old phone or computer, you're still going to be able to buy that widget. They don't care. I mean, they would like you to be updated, but they're going to take your money over a TLS 1.2 connection. All of these links, I'm going to go fast because you're going to be able to find these in the slides and look them up online. So I'm going to skip through here pretty quickly. But if you guys have any questions, just speak up. And you can tell if you're speaking loud enough, because you'll see if the speech-to-text AI is capturing it right. Okay, so the tool I was mentioning, if you don't want to go to a graphical website, and when I did the dry runs, I was actually going to do vibe coding in between, but those sessions went way over an hour, so I'm not going to bring my terminal up and run Qualys. I'll show you some screenshots. But if you guys run any version of Mac, Linux, or even Windows PowerShell, you can get SSL scan and at a command line without having to go to a GUI. You can see what ciphers you're communicating with Amazon or your bank or your favorite website. You could check out what they're using. So this is a tool called by a vendor called Qualys SSL Labs, and they measure about 4 pages of stuff, like what ciphers you're using, whose certificate it is, and then metadata, like what kind of devices you would work on and what you wouldn't. And you could as you're working on your website, you could take ciphers out and then go back and run a 1-minute test and say, oh, when I took that cipher out, I'm not working with like OS 7 anymore, Mac OS 7, you know, and some of my users still might be using, you know, their 12-year-old Mac and they can't upgrade beyond to something later, and I still want their business. So you might put in, determine what protocols you're using, depending on your use. If you're working at doing a website for a school, and you know the school has a low budget and has 10-year-old computers, you'd want to make sure their Windows 8 or whatever things, or Windows 10 things, early 10, still work, so they don't get errors when they come to the website. If you're doing HTTPS on the website, you're always going to be using port 443 by default for people coming in on a browser. If you're doing dev work or you're doing your own API, you can make the port whatever you want. But by default, it's got to be 443. A lot of, when you install things like Apache or Nginx or Internet Explorer, whatever your favorite web server is, it's usually going to open port 80 because that's traditionally been the HTTP port. And if your firewalls still have it open, which they might, because people still use HTTP for... Go ahead.
I was going to ask you, you mentioned historically that's been the case. What about moving forward? Is that still going to be, in your opinion, port?
I would say no. There's very specific use cases where it will always be open. One is dev use. Another is certain places like captive portals. If you don't have an HTTP site to get around, you kind of get stuck in the captive portal. So there are some sites out there that are called like HTTP Forever that will be there. But going forward, most security recommendations are to close it. And the reason why the last 5 or 10 years it's been open, even though HTTPS was required by all the government and
NIST recommendation too?
Standards, yeah. Okay. The reason why firewalls would open it is because before browsers got smart, if you typed in like Microsoft.com, the browser wouldn't know to redirect it to HTTPS. So if it weren't cached or cookied, it would say, you know, error, and you'd have to type in HTTP or HTTPS. So if it's still open, you can code it. So you're saying, hey, every time someone just doesn't put www or doesn't put a prefix for HTTP or HTTPS, just forward it to HTTPS. And that's kind of a hack because that request is going in plain text.
So is it still that's a vulnerability, you're saying that? Because if companies are going to be turning over.
Yeah.
Okay.
Yeah, I mean, it won't be a CVE 9 level, but any scanning test will just give you an info message saying, hey, port 80 is open, by the way. Is there another question? Oh, okay. So in Nginx, and I'm going to skip through these coding examples, but okay. I'm supposed to be done with these, so I'm going to start flying through these. Okay. These are all going to be in the slides on how to like get around port 80, how to make sure port 80 goes to 443. But you don't need to. You'll get a security flag, not a high one, but you'll get an info message that you're using something. You're sending data. You're allowing data to be out there that's not encrypted. Again, these code examples I'm going to let you look at on your own in the slides because they're also using Nginx, and many of you might be using Apache or Tomcat or some other web server software. That's fine. I want to make note that as we talk about ciphers, there's different naming conventions that OpenSSL will use versus, say, IANA. And so you might need to Wikipedia what the differences are, and when we get into web servers, you actually have cipher suites. You have multiple ciphers going on. Everything's TLS or should be, but that's still the protocol. It's theoretically possible to put up an SSL site right now, although it would have a lot of vulnerabilities. The bulk cipher says this is AES, Advanced Encryption Suite, 128 bits and GCM, and then it's also giving the hash base, or the HMAC, the message authentication code type. This is an example string. Okay, I'm going to skip through this coding. If we have time at the end and there are questions, we can go through it. I'm also putting my email at the end of the slides if you have any questions on these examples. So key exchange, I'm actually going to get into post-quantum a little bit right now. So the key exchange, the part of the TLS 1.2 and 1.3 handshake between the client and the server, the first thing it has to do is it has to say, we have to standardize on how we're going to talk to each other. And in the past, or now, that's done by things like RSA and Diffie-Hellman. And in the last 10 years, we got a new one called EC, or elliptic curve. And elliptic curve is actually preferred and the default in 1.3. Even though elliptic curve and RSA are not going to cut it for post-quantum, they're preferred now. Anyone want to take a guess why?
Elliptical curves use a lot less power.
Yeah. So more than half, if you go to those SSL Pulse or Google or Cloudflare sites, more than half the traffic in almost any demographic or geographic region you look at, more than half the traffic's mobile. And mobile, you don't have, a big Xeon multi-core doing AES-NI. You're not getting hardware offload. I mean, you might be in a modern phone, but somebody with, 5-year-old Android, it's a heavy load, and elliptic curve offloads a lot of it's a lot more efficient. We're going to see problems with elliptic curve in a minute. Okay, so this is just a chart you guys can look at. RSA's been with us for 25, 35 years. A buddy of mine was going to be I'm from the Bay Area, and RSA was in Redwood City. So Revere, I'm going to mangle it. Ravis Shamir Edelman, a buddy of mine, Al Alcorn, was offered to be RSAA, but he was already doing really well, making the game Pong, working for Nolan Bushnell, and becoming an Apple fellow. So he didn't take that position, but he did a lot of other cool things at that time. So this is just a table. Again, elliptic curve is the default in TLS 1.3. And it's probably going to be good for another 5 years or so, but we don't know. We don't know when. We do know it's vulnerable to quantum computing. So some examples of things that have been deprecated in the last year to 10 years are SHA-1. So the reason why we should listen to people like NIST is because they actually were warning us in about 2015 that SHA-1 was vulnerable to collisions, and even though the math for these SHA algorithms is great, they're not broken by brute force. They're broken by the way the algorithms are designed. So SHA-1 was broken or was shown to be broken in 2017 by Google and some security companies. And they said, look, we're going to mention this to everyone. We're not going to tell how we did it for 30 or 90 days. And they basically, in 2017, published a PowerPoint slide that had the same SHA-1 hash with different colors. So you open the PowerPoint of file A, and it was like red. And then you open file B with the exact same hash, and it was like green. You could see, okay, this is broken. So certificate authorities, whether it's GoDaddy for $5 or Let's Encrypt for free or DigiCert, they don't allow SHA-1 hashes anymore. Triple DES, which was the old 56-bit DES tripled by 3, is considered invalid. Probably was like 10 years ago, but these are still in FIPS 140-2, and 140-2 is actually good till like September of this year. So not for anybody submitting new, but if you're an old company doing government stuff, you theoretically could be using some of these old protocols up until later this year. Shorter key sizes are also deprecated. Okay, so to get 100% and not 80 or 90% on these charts, you need to support TLS 1.2 and 1.3, and that's also NIST recommendations and in many cases requirements for things like HIPAA, HITRUST, and FedRAMP. You also want to use to score high on the tests by security vendors like Qualys.
I noticed something, 4,096 bits RSA from California, that's a requirement?
It's not a requirement, it's a recommendation.
Okay.
And that's for your server cert or your load balancer cert, not for an intermediate cert.
Okay.
A lot of people will contest that, and they'll say there's nothing that can break my 2048, and I'm not going to argue with that. I'm just going to say, yeah, but you're not going to get 100% on Qualys. Yeah, so, I'm not going to go down that rabbit hole. Okay, so Mozilla, because this is an open source event, Mozilla keeps track of these, and they're pretty good, but they're always a few years behind. So you can always go to Mozilla and say, I want the compatible config, the weak config, or I want the medium config, or hey, I'm setting up TLS or web server on my LAN or with my small company of 10 engineers. I want the highest security. So you can always go there for a reference. If you plan to sell to the government, you can look at the government stuff and whether you want to pony up all the certification or use FIPS compliant stuff, which will be a surcharge. You may not want to you may be a software vendor, but you may want to say, I want to buy Red Hat, or maybe you even do crypto in your application. But you say, I don't have 6 months and I don't want to write 500 pages of documentation. So you can work with a third-party vendor. And there's third-party vendors like Wolf SSL or people who depending on how you interact with their SSL module, they already did that legwork with NIST to get FIPS certified. Okay, so now we're going to get into post-quantum. So nobody knows when quantum computers are going to break classical or current or say an elliptic curve technologies. But NIST thinks it's going to be around 2030 or in about 5 years. It could be next year though. I mean, we know every time somebody publishes how many quantum computers out there, it's usually double the number I've seen before. So the last number I've seen there are about 200 running in non-test mode. And we know China has them. We know our government has them. We know IBM and Google have them internally. I know I can go on AWS bracket and run 3 different brands. Although it's pricey, it would be like 30 cents a query to do Shor's algorithm, which tries to break public key cryptography. So nobody knows. I certainly don't. But I'll give you some tables that NIST provides. I'm gonna talk about the new ciphers first. So these ciphers have, or NIST has known about the quantum threat for about 10 years, and they've been working since 2016 or 2017, both internally and with cryptologists around the world, cryptanalysts, to try to come up with different types of algorithms that would be quantum resistant. They've actually settled on what will be the first ones, and it's called module lattice-based key encapsulation mechanism. And this is going to replace things like RSA and elliptic curve, and they're calling it MLKEM. And they also have a backup that just got decided in March or last month, and the backup is going to be HQC, which isn't lattice-based. They don't know that, they believe lattice-based algorithms will be quantum resistant, but if for some reason it's not, HQC is now a backup for MLKEM. For the signature algorithm for post-quantum, they've identified it as MLDSA, which is also lattice-based. And for the hash, the signature algorithm, they're still going to allow high-bit SHA-2s and the existing SHA-3 that's in OpenSSL. And they've also identified with FIPS 205 SLHDSA. And there's another one called FNDSA, which is a fast Fourier transform over NTRU lattice-based digital signature algorithm. So make note of these 5 when you download the slides, because you'll see a lot of referencing, and you'll see that number 1 is already being used in 2% of the traffic. So Cloudflare and Google are already using it in a hybrid manner.
What about a rollback to sending checks by mail?
Yeah, rollback's good. In fact, OpenSSL 3.5, which I compiled a week or 2 ago, it's not doing away with RC4, Ron's Code 4, that was broken 25 years ago. It's still in the suite. So it's good to have these old ones, because even though we know that they're not perfect, we know that they were NIST certified at some point. So when you use something like a library, like OpenSSL, you get all these cipher suites. If you decide to do something vibe codey, like WireGuard, and you say, oh, I've got this cool new lightweight VPN thing, and it's, only half the code of OpenSSL. Then you have to make compromises. You say, okay, I'm going to stick with this Cha-Cha-20 and Poly 1305 combination. And if you were using those and you, in a FedRAMP environment, say over the last 2 years, every 2 months, you'd have to stop using it because there were vulnerabilities, not with Cha-Cha-20 or Poly 1305, but the way OpenSSH implemented it. So the fix, they didn't have to change those ciphers, which are still considered strong, but the way OpenSSH, a sister library to OpenSSL, interacted with it had to get patched. So if you're going to be in a compliant, always-up environment, no matter what kind of CVEs are coming tomorrow, you'll probably want to use a library or a library vendor, whether it's OpenSSL or Bouncy Castle or Crypt Wolf SSL. You're going to want someone with multiple ciphers and backups without having to down your service. Okay, so in 2025, We've had a bunch of change in government stuff going on, but basically the plan has always been in 2025 to be post-quantum ready for all government services. So this means, state and federal, getting your vehicle tags renewed, getting your Social Security, getting your taxes done. Everything was supposed to be done. And now it got delayed. It's still they're still hoping for it to be 2025, but you're going to have to follow that because, there have been cuts and changes going on around this. But there have been executive orders done on this, but we've seen executive orders get canceled or delayed too. So what can we do now? So if you're using Chrome or Firefox today and you do the updates every week or two to get the latest version, your client in those browsers is already supporting the lattice-based MLKEM. So if you talk to a website, like if you talk to an example is if you talk to let's see, I think it's PQ for postquantum.cloudflareresearch.com with your Chrome or Firefox browser. And then you right click on your mouse and bring up the dev tools, inspect, and then you go to more tools, privacy, and see what protocol you're talking to, your browser's talking to that server. You'll see it's using quantum resistant MLKEM. And you may wonder, well, why do I care? Because I read the news today, and there's no quantum crack yet. And NIST even thinks it might be 2030. The reason is because of this harvest now, decrypt later, or save now, decrypt later. So any traffic you have going back and forth, anybody in the middle, or any cloud provider, or any Cisco router between your ISP or whatever, you and your destination, can save that traffic. And right now we know it's encrypted, but wouldn't you rather feel better if it's crypto encrypted? So, whatever you're writing isn't decrypted in 5 years by some script kiddie with access to a quantum computer. I think it's a good thing. I sleep a lot better knowing that. Yeah, go ahead.
Didn't NIST suggest some quantum things? They had cutesy names like dilithium and whatnot.
Yes.
And those were broken, one of which by conventional analysis. So if the ones they're recommending are wrong, what are we supposed to use?
Well, that's why every 3 months, they keep eliminating some. So they used to be called Kyber and crystal dilithium before they went to the ML-KEM. And many of them were broken. And in many cases, the authors, often they're paid people. A lot of these people are like Google people or working for governments in Germany or the UK, and they're scientists getting paid. And you can actually, if you go to the NIST pages, you can actually read the commentary of the scientists acknowledging why they weren't picked. So you'll realize why this has been going on with scientists for the last 9 or 10 years and open to the public since 2022 to comment and read. So it's not a secret that our first attempts with crypto do have vulnerabilities. But the ones that we have now, these 5, they're not known to have any vulnerabilities. But they might. That's why we have a backup HQC that's not lattice-based. So I'm gonna keep going. That's a very good question. Okay, so these. Okay, so let me go page up again. Okay, there's a lot of things you're gonna have to read fast. Okay. Okay, so this table, again, on the right, you're going to see deprecated and then disallowed. This is going to be, again, relevant to things like standards based on NIPS like FedRAMP. So if you're running your own stuff and you're a vendor and you're not taking credit cards, you're not doing health data, you're not dealing with PII, you won't have to follow these. Just like you can put a website up today for your neighbors that doesn't have a certificate. You know, it might be, and it might be fine. It might be a static sign like, you know, cookie sale tomorrow. You know, and you don't care if anyone trusts it or not. You put it out there for your 3 neighbors or something. But if you want to meet regulations and standards, you're going to have to plan on moving to these. And I'm recommending that you do now, because if you look at the middle chart, and I grabbed the screenshot, but if you look at this, okay, if you look at this one in white, and I give the link, this is today, this came out at the end of March or early April 2025, and this is a 5-year LTS release. OpenSSL 3.5 is going to be supported till 2030. These ones here, like Ubuntu, they're not LTS. They're only going to be good for 13 months. So I like LTSs, so I compiled this. I git pulled it, compiled it. Well, the compilation took about an hour, but the commands were only about 5 commands. It's just you run a make and a make install, and then you make sure it's in your path, and then you do OpenSSL version, and you get 3.5.0, and that supports all those 5 quantum ones, and it will be updated. So if MLKEM is broken and we have to go to HQC, it'll get updated.
I hate to ask you this question, but how far can you go Windows NT?
How far back can you go? With post-quantum, no. And if you go to the Qualsys website and you go to an old website, you'll actually see what devices. It won't go, I don't think it'll go to NT, but it might show some like Windows 7 or 8, and it might show some Android 4s. It will show some 15-year-old devices. Because remember, unlike us consumers, governments and big enterprises, they can do deals with Microsoft that say, hey, I put Windows in NT in my Boeing 737 and I want it supported till 2040. So they're going to get patches that us public can't get. So NT in a 737 is probably crypto certified. But the ones that you and I built from the CD we got at Best Buy 15 years ago or Circuit City, that's probably not going to be supported. So these sites like Qualsys can actually show you what devices and versions, things like TLS 1.2 got patched. But for 1.3 and post-quantum, I doubt it. I doubt that 737 is going to be post-quantum unless it's retrofitted. And there probably is a plan for it. I mean, they're talking about the F-35 running on Kubernetes because, you know, if your left wing gets shot off, you want those containers moved to the right wing. Okay, so these are open. And we also don't have to worry about, I know there's a lot of Canadians here, we don't have to worry about one country barring them from Canada or Mexico, because these are actually being authored by Canadians, Europeans, maybe even China and Russia. So NIST standards are not going to be like DES. The NSA still does Suite A and Suite B, and that's usually hardware related type stuff. But the crypto's as strong, it's not necessarily any stronger than NIST. It's mainly hardware things that have to do that sit at the edges of clouds that has to be like physically tamper-proof and all that kind of stuff. They're called HSM, hardware security modules. The ones the US government likes a lot are actually made by a company called Thales, and they bought a bunch of companies, SafeNet and others. They're actually like designed and made in like France and the UK. But they're using NIST algorithms, of course. So they're open. You can download the source code from Git. You can always make your own. You can always say, I'm going to take these algorithms and add a secret seed and call it TEDS MLKEM. and nobody's going to trust it but you. You'll know it's special. But FedRAMP and NIST, when it's not on their list, no matter how strong of a algorithm it is, they consider it having zero strength. And there's, you can go down a rabbit hole with that, but I don't want to go there.
So if you take one of like their approved algorithms and you like layer it with something different, is that still approved?
No. And that would, you could do defense in depth, like onions of a layer, like you could encrypt here, and encrypt on the machine. But you cannot combine the algorithms and say, I'm going to do triple MLKM. That would be zero encryption. And again, that goes back to Kirchhoff's law, the guy who said, or theorem rather, not a law. The guy who says, we need transparency so everybody can see, that they're using strength and science and not security by obscurity. Where someone just comes out with a scanner and where we used to think, oh, we'll change my SSH port from 22 to 381278, and we realized, oh, it's a guy's using a scanner for all the ports, and so Kirchhoff's law, we want the government wants transparency. So thank you, and all these slides, I'll have there's a bunch of other slides just for you to look at. And if you want this document, I'll actually put where you can get it right now. You can get it at slady.org, LinuxFest Northwest _2025 securing your web server.pdf. And I'll see.
Is that a secure web server?
Yeah, it is. And if we have time, I'll prove it to you. Actually, I don't have it post-quantum yet. It's just TLS 1.3.